Okay, so here's this is one of those your turn exercises in Think Do Chapter 3 book. And so the question somebody asked is, I'm trying to do this anonymously so I can use this video in future semesters. So sorry if I'm being vague. So this is about, what is this? This is test scores. Let's see, the mean scores of females. So how does it keep? I don't remember. Anyway, that's not where we're going to go with this. So when I add this up, I get a total of what? 5, well, let's see, 11. Well, let's do it this way: 10, 20, 30. So there's 30 people in that group on this chart that this represents. So then if I want to do the relative frequency, all right, that is, I'm going to take each one of these numbers, the counts, and I'm going to figure out, instead of doing counts, I'm going to do percentages. So 0 divided by 30 times 100 is 0%. So 0% of the distribution was in the 30 to 39 range. 1 divided by 30, then make that a percentage. So 1 divided by 30, let's see, I'm doing this off screen. That's all right. So 3.3% of this distribution was in between 40 and 49. And then 4 divided by 30 is 13.3%. And then 6 divided by 30 is 20%. I should have been able to do that one in my head. I'm sorry. 9 divided by 30. Let's see. Can I do that in my head? 30%. I should have been able to, but it's the end of a long day. I've already done 6 up there, so 20%. And 4 divided by 30 I've already done, that's 13.3%. So this would give us another way to look at, sometimes it's good to look at the percentages that fall in each bin. If you were to graph, if you were to do a histogram and graph, let's see, where's my spotlight? If you were to graph the histogram with these on the x-axis, these on the y-axis, and then make another histogram with these on the x-axis and these on the y-axis, they'd look exactly the same, as long as you used a scale that wasn't really whacked, but depending on the scale, they'd look exactly the same. Now, if I wanted to, sometimes it's good to talk about cumulative. Like I want to know how many of the distribution, I'm going to erase this relative. No, I actually need that, so I'm not going to erase it. If I want to do the cumulative frequency, can I spell that? Frequency, I'm just going to say, so there is 0 here, and then 0 plus 1 that fell in this range would be a total of 1. And then there plus 4 there'd be 5. So from the 30 to 39 criteria or class up to the 59 or just under 60 would have 5 of the individuals. 5 of the 30 individuals would be there. And then we'd just keep going. 5 plus 6 would be 11. 11 plus 9 is 20. Then 26 and 30. So, and of course we would know that 100% of the distribution would fall at or below this last class, right? So that's that. And this, what that bar graph, what that histogram would look like is you'd have your bars and they just constantly start growing, right? Like that. Another name for this is a Pareto. It's a form of a Pareto graph. Business types like Pareto. Pareto was a statistician, a business analyst years ago that came up with this chart for businesses to use to look at trends. That's all what this is about, is to get a picture of what this distribution looks like, right? Then the last thing you asked was about a cumulative relative frequency. Well, for the 0 class, there was 0. Then I'm going to do the same thing. I'm just going to start adding up those relative frequencies. So the next class would have 16.6%. I'm not writing a percent here. I should be, but I'm not. 20, then I'll add 20, so that's 36.6%. So it's kind of interesting with only 4 of the 7 bins or classes accumulated, I've only got 36% of about 37% of the distribution. There or less. So that can help. That can help us figure out percentiles and stuff. You've done percentiles with in chapter 2, so it's just another extension of talking about percentiles. Now we're going to go with distributions and areas under the curve and not go any calculus if that means calculus to you. So don't worry about calculus. I shouldn't have said that. So the next one will be 66.6%. Yes, you can do all this with calculus, and it has a lot more strength than I don't think I added this up right. Let's see, 36.6%. Yeah, plus 30 is 66.6%. And then we'll get 86.6%. And then 86.6 plus 13.3 should be 100%. I think it is. Sometimes it's a little off because of rounding. But that's sort of cumulative relative frequency. And then you could draw a histogram, right? It would be the same kind of thing. You'd have percentages, your relative frequencies here, and those bars would just start growing until they were 100%. Okay. So what are they good for? I don't know. There are all kinds of different uses. It all depends what you're trying to show. I hope this answers your question. Give me a yell if it doesn't.